We'll go back one here. It kind of wraps us up there. Yeah, just fill those out and post them. If it's driving you crazy, you can print something if you need to for sure, whether it's the worksheets or the appendix. But I'm gonna jump into Block Gasket. Maybe I can't finish this, but we can get going, and I will have some data. But so I've got my inch template open already in CAD. I'll pick my scale once I get there. I need to use tabular dimensioning for the second time. And I can use arrow, and I guess the difference is I'll use that arrowless dimensioning, so I want to use ordinate dimensioning. And this one can just be a front view because it's a gasket, so I can kind of look, I can designate thickness in the notes probably on this one. Don't really need to show gaskets are pretty commonly just single view drawings. The only difference is if I read through this, we're going to convert this sketch in here to arrowless. So I've been supplied with just our standard dimensioning styles here. I think I determined that, oh, this probably would work. Like if you had dimensioned something like this, it's actually good dimensioning. It's actually not crazy oversaturated, and it probably show up good on a drawing. So but a tabular dimension will be easier to pull dimensions into another program. Like it's already kind of a little table spreadsheet as a tabular dimension style. So maybe it's easier for someone downstream from you to pull the dimensions from your table into a program. So it tells me what I want in my table, hole diameters, arc radii, and the location from XYZ coordinate or XY coordinates. Um, then it just tells us about how, okay, our UCS has positive, 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 negative, 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 and negative positive type of the coordinates that'll be spit out. If I put so this does have a particular like 0, 0 point on this for sure. So on your AutoCAD drawing, rotate the object 90 degrees from how the picture shows below. This will orient the x-axis horizontal and the y-axis vertical because it's kind of backwards here. Uh, use ordinate dimensions for the values not in the table. Oh yeah, okay. So there are a few dimensions we put on the actual part. Um, I have had a few people work ahead of this already, and they've recognized that it's not clear on what the dimension is. There is kind of a missing dimension on this particular problem. And once yeah, it was Kennedy working on this earlier this week, and I remembered, oh yeah, there is kind of a missing dimension here. So they have a lot of dimensions, but it was locating this rectangular feature here. Um, it is given from center the size of this rectangle, but it's not given both sides of it this way. I've got 1.494 from the x-axis down to the lower, and then I'm not given a specific one. It doesn't quite line up with the center lines here. You can kind of see there is a jog there. And so this wasn't given. And so I think I ended up having to make this up is what I did when I did mine. So if I scroll down, I do have some imagery down here. This is how mine's going to finish up here, but I did either make up this dimension or at least I applied it. I'm sure I just made it up because it wasn't given. This shows, and this kind of shows the relationship. It's close to the center lines, but it's not exactly these center lines. And so it's this point 1, 2, 4. I chose to make that its dimension. So yeah, what I remember. I zoom back out here. There we go. So where that's missing up here, if you have this as a reference, you can find it. And let's do this then. Let's draw this thing out. Um, I'm going to open up this assignment sheet. I won't work from my other one. I'll work from this one. And I don't think I have that pulled up yet though. Week 10 block gasket. It's this one. So I have this up in my Word document, which is what's attached to the assignment. Yep. And then this is this is the same image on the last assignment, just showing that it does come out of the code book that we use, that is our ruling body. So this is a standard, an ASME standard type of dimensioning. Okay, so I'll pull this over and go to town on this, knowing that I've got to rotate it. And then I think one thing I did point out, maybe one on my example is here. Notice with your ordinate style dimensioning, arrowless ordinate dimensioning, I'm still using those as positive values. I pointed this out the other day too when I talked through it briefly. These are positive values. However, in the table, I am putting its actual coordinate value in. So there are some negative values here because of where they put the 0, 0 point. 0, 0 is located right here. So I'm pretty much going to start building this thing from 0, 0 out is how I'm going to start this. But there are a bunch of different ways you could start. But so I'm going to go. I've got my B size sheet opened up, my inch B size, and I'm going to go start drawing this thing out. So to me, there's a radius of 6, and I'm going to use the 3 decimal places. It looks the other thing to note here, I guess, as I think about if you've like finished it up, our dimension style is just 2 decimal places. So we could probably create a third dimension style, would probably be the best. And that's just because from the engineering sketch that I'm given, these are all held to 3 decimal places. So when I get to the dimensioning side of this, my 2 decimal place system isn't going to be sufficient to carry this data. I've got to kick it out to 3 dimensions. I think every dimension I see in here is 3 decimal place. So for those of you that have worked ahead and maybe you're at that stage, maybe I'll create that real quick just because I know that I'm going to need it. So I'm back into here. If I go in, just so if I address that issue right off the top, I'm going to go into my dimension styles here. And this is the ISU template. So it does have some stuff built up and ready for tolerancing type problems that will be coming in our future. I still don't have just a simple 3 decimal place, so I could build one. Yes, I could go in and change one and then go through and click everything, but where I have everything as a 3 decimal place, it'd be smarter to just create a dimension style. So I'm going to create one. Whichever one, I'm going to select one to create from. It'll kind of be the backbone of what I'm going to create. So I'm going to say this one, but new. And it's going to be based off of this one here. And I'm just going to say, oh, it's not going to be copy of, it's going to be 3 decimal place or something. Just something that I can recognize it from a table of dimension styles. So 3 decimals. Start with 2 decimal though. It's going to be annotative. Let's say yes, continue. So the only thing I should have to change is just the precision of this dimension style. So I like everything else about the ASME 2 decimal place dimension style. The only thing I'm looking for is where the precision is housed here to change it. So if you just click through here, if you're not sure, you just click through here on these tabs and look for where, bam, here it is. It's on the primary units tab. We're in decimals and we are holding 2 decimal places. So all I gotta do is change this to 3 decimal place. And I see that show up as it'll be a 3 decimal place dimension style. That's all I really want to do. Okay. And I'm going to set that one as my current. Yeah.
Do we want to that same 3 decimal on the inner dimension? If I'm big still at 2.
Oh, on the let's see here. For on the actual on this worksheet, they're showing, do we have some angular dimensions here? Or you're just saying on my style? Yeah, I would potentially if my drawing needed it. If it doesn't need it, then I'm not going to. And yeah. I view here that I'm actually not even going to use an angular dimension likely, but that is a good thing to wonder. And if I did, I would just need to watch my, yeah. I would say I wouldn't do it unless I was given some angular dimensions in 3 decimal places. If they weren't, I would just keep it as my basic 2. But that's good. Yeah, yeah. Whether I change everything within it or not, I see what you're saying. Yeah. Because I'll go back in there and say, let me modify that again. And on the primary units, I changed to 3, but down here I did not, is what you're saying. Yeah, I think that's just a good thing to pay attention to and change it if you needed to. So yeah, I like that question. Good. I'll leave mine unless I think I need it. Yeah. Okay. I'm gonna set that as my current though. Not that I need it now, but that's how I would address an issue like that. And then I have it ready to go when I'm ready to mention. So let's draw though. I'm going to build this thing from the center out. Somewhere I have a document, this thing. I'm going to pull it back over to my other screen. Yeah, I'm just building this thing from this point out. So I'm going to put a circle. I'm going to probably build this rectangle, and then I'm going to maybe draw this rectangle out. So I'm just going to follow these dimensions and piece visible lines together here, right? So however you want to do that, it's fine. I'm just going to start with a circle that's at 0, tab 0. That way um, I'm at the origin point here. This one has a radius of 0.61. That should be this one has a radius of 0.61. Yep. Need to make mine a little bigger so I can see it. Point 0.57 down. Yeah, this one kind of is what's that? Just in my drawing here, right? So I'm just you better have this up or you're not gonna be there's a oh yeah, right here. That's where I'm starting. This is my 0, 0 right here. 0. This is the x-axis they have labeled here. It's pretty small labeling here. It's kind of hard, easy to miss. There's x, and here's y. We're just flipping that thing 90 degrees so that it's actually in our normal CAD layout orientation. Guess you could build it the other way and then just rotate it around. But let's see. Do I have everything? I think so. Yeah, so however you want to do this, I'm gonna draw some extents out of this. I'm doing some construction work. This is in the X direction this way, it's 2.04. Oh, sorry, I'm not sure why that didn't like my input there. That's weird. I'm starting here. Oh, I'm in like some weird 0 tab 0. I'm gonna draw this thing. It didn't like me. I don't think I'd actually snap down. So I actually just entered that I'm starting at 0, 0. So yeah, just build this however you want. 0, 4. It's not the same direct, it's offset. It's not symmetrical from the y-axis for sure. So just watch yourself that way. My shape is going to be out here, 2.04 this way, and the other direction it's going to be I'm going to go to 0, 0. So I'm just entering those coordinate points and it'll snap for me. And then this way it's only 2.035. Yeah, I like this assignment because it's just a little more particular, but that is not symmetrical through the y-axis actually. It's longer to the right than it is to the left when I've rotated this. And I guess would you say, well, how do I know which way I'm going to rotate this 90 degrees? And I think that's a valid argument. Nobody made it, but I'm making it myself. Do you rotate this down this way or do you rotate this up this way? And that's not really clear from the instructions. It just says rotate 90 degrees. So technically, you know, because all of their dimensions are positive values, you wouldn't really know which coordinate they wanted up or down. So I just kind of made an assumption that I was going to rotate it like counterclockwise 90 degrees. So that's why my assignment sheet ended up having it oriented this way. But I could view that some drafter would read those same instructions and say, well, I rotated mine the other way. Does it matter? And it probably would matter, especially if I'm building something by coordinate points. But it's not clear on the assignment sheet which way I've rotated that, unless you have my little example here. So that should be something I should like designate which one is the Y. What the assignment sheet would be better if it said, if I had like something that said this is the positive coordinate or positive coordinate value quadrant here. I should add a note to that that says make this corner in the positive quadrant, which is what I've done. But right here, I have Z. The only thing I've drawn is just yeah 2.035. But there's a bazillion dimensions on here to get confused. It's great. and they're all different from one side to the other. Super. So this one just takes maybe a little longer to like just get it pieced together, but I'm just doing some construction work to start that out. So, and then I'm going to draw the extents of how far it comes above the x-axis here, which I think is 0.765. So like I'm saying, you don't have to draw it my way at all, as long as you're just using the data that's there. And then I'm going to draw the extent of the rectangle down from 0, 0. And I have that it's a little bit longer this way, right? It's 1.555. So that's that. So I could kind of piece this together maybe. I'm just kind of using my snap tracking to help me just like lock this thing together with those points kind of. C for close, if you can remember, C enter is close. That's essentially the extents of my part and how it's going to fit here, right? Heck yes. I'll draw in my outer line here. So I'm going to switch over and trace that over with my, probably just a rectangle maybe. Draw a rectangle, snap it to that. This is one you might want to keep track of. This is definitely one as you're piecing stuff together. It is helpful to keep track with something to make sure you haven't fat fingered a dimension somewhere and end up with the wrong dimension, and you wouldn't know until you start to dimension stuff out that you've slightly missed stuff. So just keep track as you build it. Um, this is a one that I'm not going. I don't know for sure, but I'm not going to assume that the outer radiuses and the holes are concentric. I'm given dimensions for the whole location, so I'm definitely going to locate these holes by these dimensions I'm given, these linear dimensions, rather than just assume they're concentric. They may or may not be. I don't know, but I'm going to go off placing those from the dimensions given. So yeah. And I think it's made to be kind of painful to piece it together, but that's what we got to do.
We'd like so much of it symmetric, but then like
But yeah, you're just
things that
worried
like obviously would be symmetric just
aren't exactly. So it's one that you just got. I think it's meant to be a gotcha, a little bit of just a lot of dimensions. So when I see something that's pretty busy like that, I'm like, well, I'm just gonna look at each feature like real closely and place it one at a time, kind of, not try to do a bunch of mirroring unless I'm really sure that I can mirror or copy. So it'll just be a little painful to build it here, but um, so I've got my overall though. I might keep. I'm gonna keep from filling these till the end. I don't know why. Just because once you fill, here's one thing that I think when I build when I have rounded edges, they can get a little like I like have. I mean, if I filleted my radius, it's one reason why I like having my construction ones underneath it because if I do choose to fillet these, which are going to be their fillets are 0.29 radius. So if I'm gonna do a fillet command and I'm gonna say the radius is 0.29. That's four of those on my print. I can see that. And then and because I've done both, this isn't going to be such a problem. But if you're used to not doing construction work, and then you do a fillet like this, and then then you might be needing to pull dimensions. I think most of these dimensions are based off the axis, so it's not a huge thing. But every once in a while, if you want to pull from an endpoint over to locate stuff, and you've done a fillet, it gets annoying to try to locate that because you've kind of lost the exact like the intersection point here. So I like my construction line, so I can actually do that to the radius here and still kind of keep a construction point out there at that extent. That's just my way of thinking that it can be annoying when you start like radiusing stuff and then you start to lose that like end to end, line to line point unless you have a construction layer underneath it or something. Helpful hint, tips and tricks, not of a pro, just of someone that's dealt with having issues to come back and locate something from this is annoying when it's turned into a radius, is all I'm saying. But with your construction work, no biggie. And then if you'd remember, like I never do, that the fillet command uh is not continuous. Dang it. Why do they not make it continuous? I have to hit multiple. But I guess I can fill it all mine because I have construction work underneath it. It's gonna carry that point that I would otherwise kind of lose. Not that you couldn't draw it in later, that's fine, but this makes me happier. And if it makes me happy, Cheryl Crow says it can't be bad. I can finish the shaping of this, I guess. I never did finish that. It goes down 0.57. So while I'm here, from the quadrant here, I'm going to go down. And I can make the same argument here a little bit. Maybe I'll initially do this with construction work because this will end up being radiused as well. 0.57 comes across to the other quadrant. Back up. Trace that over. Do some trim now. This thing gets trimmed out, right? And the last detail on that is I will put in its fillet of 0.06. So I need to set a new radius, 0.06. It's essentially a real shorthand notation of a 16th radius. 0.0625 is 1/16 of an inch. Double check my 0.06. Yeah. 0.06. Yep. So that feature's done. Now I can start placing a bunch of holes. Maybe I'll do the other rectangular feature down here. I think it also has radiuses, doesn't it? Yeah, real small, real slight radius. 0.005. Yeah. So what's up, Travis?
We should ask him to ask the people.
Is it time to go get the people? Oh,
Mine's
I don't. Oh, yeah, so I'll probably draw till about 9:45 and then I'll call it. I know I won't get crazy far along, but I can pick up and finish my video after my other classes that I got to teach today. Let's see. Yeah, and so just like not trusting the thing. I'm looking at my rectangle here now, and I'm gonna start drawing this, but it really is only located to one side, right? So I'm gonna assume this is dangerous, but there isn't a dimension different in the X direction here from center this way or this way. So I think I put mine as both 2.76 off of the Y axis here. So that's where things are not totally off, totally the same. It's a little bit dangerous to think that that's centered over center line. But I'll draw it that way, and then if I was the drafter, I probably here's the way I think too is sometimes I would come across something that I've got a lot of data for from an engineer, right? Like they've given me a lot of work to start, so I'm gonna get to town, go to town working on this. Yes, I might come across there's a few questions. I'm just gonna like make note of those as I draw. I might draw them in thinking, well, it doesn't say it's different, so I'll put it in symmetrical, but I'll make a little note to myself. I'm going to ask the engineer before I lock this down if that's symmetrical there, where this part's a little bit, or I'm going to have to go reference a model what this fits to or something. I might have to do a little bit of homework research to find out, see if I can find an answer to my questions. I tend not to be just like get up, run away to someone and say, hey, I've only done about 10% of this drawing, but I've already found an issue. What is this? I might sit here and proceed to like put everything in that is for sure verified, and then I might go ask a question. So, that's the way I worked in my life a little bit. Like, I'll work with what I got. I'll write down the questions I really have. Then when I get with the engineer, we can sit down and I might work for 10 minutes, find an issue, run and say, hey, what's this dimension? And then I sit down for another 20 minutes and run and say, hey, this dimension's missing too, rather than maybe I could build a list of questions, maybe 5 or 6, and then when I sit down with the engineer, we address them all at the same time. That's nice way of thinking. Just because I have so much data to work with, there's a lot that I don't know that I can just keep working with what I do know. And maybe while I'm working along, here comes the engineer and he's like, "Hey, how's it going?" I'm like, "Hey, actually, while you're here, this is missing." You know what I mean? Yeah. Don't run and cry wolf yet. Just write down that there is something that you need to ask. Okay, so I've got that up. Mm, 276. So I'm going to draw it in with what I think, and then I would check myself. Let's clear down to pretty close, yeah. This way. I went down to the bottom of it, which is 1.494. That's how far I cursor down before I put in this line that's 0.276 long. And then I don't have its width dimension given to me. In fact, that's the missing dimension for the most part. So this is going to come up this way. I don't know how far. I just drew it up way potentially wrong. This way is the one I'm still not clear exactly, but I'm going to put it in the symmetrical. So it's 0.276 this way. This I'm just going to snap in long. And then I'm going to cursor down for the other point across here. Um, it is definitely got to be from this one here. I'm going to go down 0.124 or 1.24 from center down for the top horizontal line. 1.24. That's what I'm going to use. So I'm going to come down here from center, cursor down 1.24 inches. That's where I've decided the top is, and I'll just put it in long and trim it to fit, right? Sweet. I might do the same thing here. This has radius, so I might take a construction layer here, and I might just trace this with a construction rectangle, really, just so I remember where it's like, and then I might send that to back or something if it'll work for me. Send to back this thing. Yeah, now I've got my visible lines on top. Because I'm going to radius all these corners too. They're like a real small radius, 0.005, like 5 thousandths of a radius on these. So they're pretty small fillet radius of 0.005. I'm going to do multiple all the way around this thing. I'm getting better. I'm remembering. How tall? I didn't do it by height that way. I did it by dimensions off of the axis. So the bottom line I put in that was off the x-axis at 1.494, and then the top line was put in from the x-axis 1.24. Yeah, that's how I located that. Yeah. Only that this is the only one that had this little sheet is the only one that has the actual location of that. Yeah, it's missing on the assignment sheet. And I've already radiused all my corners, I think. Really small radius, but I got them all. Okay, cool. Now it's holes, holes, and more holes.
That rectangle, the smallest
Ra-
fillet possible.
They're pretty small. 5 thousandths a small fillet. Exactly right. Just barely, but required. Technically, it's got a weird term to it too. It says max. It's like I could make a bigger, or I could make a smaller one even if I wanted to. 4 times radius of 0.005 max. So it's actually critical that I'm not, yeah.
The tool, that corner.
Yeah.
Pretty much a perfect corner as far
Pretty
as
much
machine goes.
just like blow on it and the corner's gone, kind of. Yeah. The radius.
Just like lasers have wider diameter than that. Why?
It's
That's
not-
a crazy precision machine.
Yeah, you can probably barely tell. Even just a normal corner cut corner to corner would be like that.
And
It might be that they, I don't know, with a lot of gaskets, they might make like a stamp, might press these out to make some type of a die punch.
You have to have a tool to make, yeah.
That's true.
Like, this right, this corner gotta come from something.
That's pretty big.
That's true. That's somebody else's problem. The nice thing about that is there is something with drafting where it's like, oh, that's your problem. I just know that it has to be that way. So however you do that, good luck. No. No, that's pretty common that you do find that sometimes engineers and drafters, the feedback is like, we can't even do that. And you're like, oh, okay. We don't know. So it is nice to know what they can and can't do. So you don't do stuff that is impossible. But yeah, that's true. That is a feedback loop that comes. Hey, you've designed and engineered something that's impossible. Does it really matter? And you'll be like, no, it'll be okay. If it was the Challenger space shuttle, then I would think it probably did matter. Somebody cut some corners.
I guess that was kind of something interesting the guys suggested, that they're like, yeah, we just designed like the outside.
Yeah, we don't have to
and, like,
detail the
machinists
parts.
And everyone else, but like, they just go and they
Yeah, that blew my. Actually, yeah, Jen was talking about that afterwards too, and I was like, yeah, that kind of surprises me because usually it's a highly controlled. Every part is usually detailed, and we don't just rely on tribal knowledge of our trades and crafts. We usually like to define stuff black and white. So that was kind of interesting to me too. That's like, what? You just let the machine shop do it how they want to do it. They did have a bunch of weld symbols on the one though, so there was like, they did have like, and everything was GD&T dimensions. So that yeah, they were using some pretty particular. I mean, they were pretty particular in their instructions on their sheets, but yeah, they didn't have individual part sheets, and that kind of surprises me. Because pretty common that yeah, we would have looked at that assembly in other industries and be like, yeah, we got to break down each part and show its details and build a whole print pack for that. That is interesting. And it might have been a less critical application too. I don't know. Yeah,
all the stuff that is critical, it's too confidential to show.
that might be it too. That they,
Random polish.
even though the simplest things are confidential out there.
Yeah.
I get it though. Yeah, I don't know. I might make some construction points for these. I mean, there is some alignment, but 1.75. I'm coming out here and making some center points for 0.475, but you can locate these however you want. I don't have great coordinate. It would be nice if I already had the coordinate points. You can see that the nature of what we're going to build is going to be a little bit easier to rebuild it. If I had a table of coordinate points, I could just input these into CAD pretty quick and just locate these circles by their coordinate points pretty fast. So, but
Start doing it, but it's probably cheating.
well, if you can, it's good. Yeah, you could use it because you can turn some of these values into negative values, right? And so you could do that. Yeah, that's actually.
It's already uploaded your job.
Oh yeah, 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 yeah. So you're already using my finished work instead of working from the hard way. Yeah, but I could do the same thing. Like if I'm trying to locate yeah, if I'm trying to locate this hole, I can just put in the coordinate points, which are going to be -2. I just have to think of which quadrant I'm in and if those are going to be positive or negative values. But I might start locating that way too. Like here's one way to locate. I'm doing a construction line. This is going to now be an endpoint center line, but maybe that's a little bit. It's a lot of extra drawing, and I could. Sorry, I didn't mean to change that to a visible layer, but yeah, yeah, yeah. I want it to be construction. So there's that way. There's that method of kind of building lines with endpoints that you can snap circles to. The other way would just be to look at your drawing and maybe look at those as coordinates and say, so if I want to do this lower one here, this is in the negative negative quadrant. So I could say, and it's X value first. So I'd say negative. I'm going to place this circle. Maybe I'm going to say it's a negative 1.75 in the X value. And then I'm going to go over and say it's also in the Y value, negative 1.265. So that's probably the way I would maybe do these is just look at those linear dimensions as coordinate points and just remember which quadrant you're in as whether they're positive or negative. So this is how I located this. And then these ones have these are a diameter. So I can hit D for diameter and say that it's 0.312. Yeah. And then there's really no construction material around it, but I can always select it and I can see its coordinate values right here, X and Y. These should match my dimensional.
Wait, how did-
Oh yeah, I'll show you. Isn't that killer, right? That's going to be the way I'm going to do this for sure. But what I'm doing is I'm looking at this because I'm working from the original assignment sheet. Because like I said, and this is what you should try to do. Even though I give you an image of it, challenge yourself to maybe work from the original assignment sheet if you want the biggest challenge. So then use that other one for your own reference material when you get a little bit lost. But when I look at these linear dimensions, and if I've located my part how I need it to be, I can look at these as coordinate points. So these are all center to center. These are X and Y located values. So so I'll just pick a circle. I'll pick this circle right here, and I'll go locate it. So what I'm going to do is I'm going to decide. I have to know which quadrant it's in. Remember, this thing's spun 90 degrees. So this quadrant over here, this is positive, positive. That's positive X, positive Y. This is negative X, positive Y quadrant. This is going to be negative Y, negative X quadrant. And this is going to be negative, or sorry, positive X, negative Y quadrant. So I have to think of that. And then I come over here and I say, this hole is located at negative X 1.75, negative 1.75, and then it's negative 0.905, and that's the center of this. So essentially, these are also coordinate points. So with that in mind, I'll show you. I'm going to go over there and put that hole in. I have to know which quadrants it's in. That's X and Y. So here's my negative quadrant. So X value first, I'm going to pick the circle command. And then if I pick the circle command and I have my dynamic input on, right? This doesn't happen. If you don't have your dynamic input on, you don't get that like coordinate point option. So that, I always think of this as Harry Potter's wizard mark down here. That's your dynamic input on your status bar. That has to be turned on. And first of all, it has to be loaded. Dynamic inputs right there. If you don't have it loaded and checked, it won't be on your status bar. Dynamic inputs. That's a good review, actually. Mine's turned on. Once I'm turned on and I'm in a command, what I'm getting is coordinate points there. Two dialog boxes of X and Y coordinate points. And so I just look at that. I look at that little dimension, and it's going to be the X value first. That's negative 1.75 tab, and it's negative 0.905. That's how I've located this location of this small one, and then I just need to know its radius, which I don't know. I should look at that before I snapped. Oh, I just have to. Looks like there's six anyway. I have to kind of pattern these. I've got my biggest holes on here. They say there's six of them. One, two, three, four, five. I count six of the 0.312 diameter holes. Then it says that the next one I see says that it's 16. I'm looking at this, by the way. Six of those. That's one, two, three, four, five, six. Those are the six they're calling out that are probably the same diameter. And then I was looking for another call out on any hole, and the only one I saw so far is this one, 16 by 187. So then I just need to count these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's really only two diameter of holes in here. 16 small holes, six larger holes, plus the other two rectangular feature of size and this other weird one. So, yeah. So I just need to know that diameter. What is it? Oh, yeah, it's 0.187, 0.187. So I'm back to here. This is by radius. So anytime you're in a radius type circle on the status or on the command line, you've got diameter as an option. If you hit D, you can always switch this to a diameter driven dimension. D, enter, or select it on that command line, right? And these are 0.187. Bam. So that's probably how I'm going to do all of these holes by coordinates. And the nice thing is, if you're used to using your properties panel up here, you can always check those coordinates by clicking this thing. And here they show up. And these are the values I'm going to copy and paste in, by the way. When I get to my table, it's probably just a matter of I go like this, copy, paste, copy, paste. I probably pull them from my properties panel, actually. You could type them in individually, but I'm going to probably copy paste from my properties. I'll have my table up with, I'll do that on my drawing, but it's probably just a copy paste option from my properties panel there. Just so you know. Because you can steal these dimensions here. If you have a feature selected you can select in here, and obviously I could change it from here too, but I can actually just copy paste this thing. Control C, Control V on my table. Cool. Let's see. So now I'm just back to locating whatever. I'll probably just kind of work from this way over somehow, left to right. I'll see if I can get all of them maybe placed here before I'm done for the day. And like I said, then I'll go back and finish mine too. And um, all of the features of size were pretty much located. One thing I will note, if you're like working ahead and you're already working on dimensioning or whatever, and I'll go back to this, you'll notice that all of kind of the whole features of size are what are listed in here. What these tables were not able to capture, and one of them was obviously a radius and diameter table, and the other one is this, and I'm holding different dimensional values because I need to match the sheet that we're given. So I'll have to show you that too. There might be some when I make this video later this afternoon. I'll show you just how I'm probably making sure that I'm carrying the right like I'm going to carry 4 decimal places for the coordinates, only because my drawing accuracy is out to 4 decimal places. So it doesn't really say in our instructions to carry those to 4 decimal places. So I just use the default. AutoCAD is drawing to 4 decimal places. That's why these coordinates have 4 decimal places. When it comes into the actual sizing, I'm using whatever it was called out on the drawing, I think. I'd have to check this because it's funny that I'm thinking I'm missing. I don't see that 0.000 or point. I don't see that 5 thousandths radius listed. So I feel like I'm missing radius. I feel like I'm missing a radius on my table, but 6129 radius 0.01. What is C radius? Um, C1. I think this is incorrect here because I think that should be the 0.005 thousandths radius. So that's weird. So I need to maybe correct this. So watch yourself before you. And I don't know where is the F radius. Am I missing a radius somewhere?
Yeah, very-
The very outside on mine. Right here, these ones. 0.06. That's right. I drew those in. That's the F rate. I think my C1 radius is incorrect on my table. For sure, it's incorrect. This needs to carry 3 decimal places to even have it accurate. And so I think it rounded up to 2 decimal places, right? So that would be the problem here. It's because it's holding 2 decimal places. It rounded me up from a 0.005 to a 0.01, which is not correct. So this is what you got to watch stuff like this. And then your table, you're able to. It's kind of like a dimension on the table. I'm able to like increase or decrease the precision or accuracy of the data in that table. So just watch yourself. I've tried to maintain. So that's the only one I see that's wrong, which is good. This is why you have your drawings checked by the second eye, is because they may catch something like that I'm decreasing accuracy of that radius by carrying the wrong decimal places. So that's super important to not do that. Anyway, but what I was going to go back here and say is that there's just data that I can't get into the table. Yes, I can get their coordinate points, I can get their radiuses and radii and diameters detailed in a table, but some of these features of size, like this odd shape here and the rectangular shape, isn't captured in the table. So that's where linear dimensions come in. I still need to have the dimensioning for those, and they're based off of a datum is our X and Y here. These control, I mean, X and Y is doing the controlling of our part. Everything is based from 0, 0. And so all my linear dimensions are from our X and Y axes because they are datums essentially. So so what I would need to know is all the overall sizes based off datums. And maybe I'm not pulling the overall size of these on these ones. I'm just pulling from the datums to their extents. And then I'm also doing that with these features of size that aren't captured in the table. That's why I've strategically chosen these as the dimensions that need to be ordinate arrowless style dimensioning to capture the rectangulars kind of features of size and some of the overall part size. But yeah, So I like my dimensioning here. I don't see that I'm missing anything dimensionally. The only thing I feel like I've really messed up is this. So and so definitely if you're having trouble with your tables once you get there, you can watch my video that will be posted later this afternoon, and I'll painstakingly build my table at the end. It's just one of the last things I do for sure. So with that being said, let's do this. That's my one that I've already done. Here's the one that I'm so far from done. Yeah, and I'll draw for another 10 minutes, then I'm gonna call it. Or maybe I'll draw till 10, essentially. Okay. And I'll have a part one and part two on this video for sure. Let's see. I just gotta keep track of which ones I gotta do. So X value on that is negative 1.66. Good. All of these by coordinate points. Larger. Diameters. Small one. Weird. I think I have one right on center, huh? Kind of. So Missing my one there, huh? Which I did draw this. I'll probably delete that out and do them all by circle this. Half my holes on the one side. Great. It only took me not too long. That's good. Hmm. Yeah.
On, right, like, you're like, people are supposed to be at 1.24, or is it the?
Is it it's these ones down here, you mean? Yeah, is it on the D features that you're saying? Or on the E? The E features? Yeah, so yeah, I guess let's check this out. So my E, like an E9 or an E8 or something. And my X and Y for E9.126. Yeah, let's see here. So yeah, this right here. This right here is what I'm putting at 1.24, the top of my rectangle. I don't think so. I'll just double check this though. The circles, to me, it looks like these circles are all on the same center line. Let me just make sure what my table says. E8 and E9. And I might have this. Let me just see. So this is my X value for E8 and E9. Let me look at the Y value actually is what I want to know. E8, E9, 1.265. And then let me just check D4, D5. D4, D5, 1.265. So I have them the same here. They're definitely not 1.24. So that would make sense. The center line's a little bit further. So now I'm going to check this here is what I'm going to check and see this dimension here and see this is 1.265. And then this side, I think it's not like super clear. There's not another dimension that comes down to it. Oh, well, yeah, this is where I think there's just some confusion. I don't know. I do feel like the 1.24 is definitely, yeah, this is, I think you're right. I think what has happened is, this is my, I don't know what's happened. I think this is how I interpreted what had happened. I think the 1.24 was supposed, that arrow should have gone to the rectangle because I think that these, where they show they're lower than the 1.24, and that's the same. If I would extend this center line, I felt like it was the same, like lower, like I almost felt like all of these were on the same center line. But I think it's arguable because I'm missing like a clear dimension. But I think when I really analyze this, and maybe I back checked another faculty's prints, maybe I don't know. But I think when I carefully analyze this, I was like, I think that these were all on the same center line as these across, and then that 1.24 is a misleading arrowhead. I think it should have showed that it's like right here, but it's hard to say, you know. Clearly there's a difference here, and the only missing dimension I had was this one, even though it's really not missing, it's just like it seems like it's misaligned. Yeah, but that's a good point, is that it's like I have that dimension, but it wasn't clear. And it could be, it's such a small difference. It could be, you know, it could be, and they don't drag these center lines through to each other to see if they are slightly offset from each other. But I think what I determined is by the nature of how far it looks like it's off the corner is that the center line for the circles should have all been the same. And I think I built my table that way. So if you didn't build it, I would be okay. Like if you've already built these holes at this dimension, I would leave them. It's okay because Nah, it's a little bit ambiguous here, but yeah. It reminds me that I got to change this. Another red line revision. This is actually why I kind of like to rebuild the assignments myself, is so I fix stuff like this. But I'm gonna make a note of that. Yeah. But I need to turn this whole assignment sheet into my own, a kind of a rewritten one. Still in, I like the orthographic misalignment and stuff, and I like all the real picky dimensions, but I would like the dimensions to be obviously correct.
So you're just saying that 1.24 inches.
The only time,
For the rec.
the only thing I use it was for the top surface of the rectangle. Yeah,
There's-
there's no other dimension for that, and it doesn't totally make sense that those holes aren't in the same like. But yeah, yeah, yeah.
Amen.
So if you build it like my table, you're probably building it like with, yeah, go ahead.
You want to know something that's really bothersome?
Okay.
The corner fillets of the whole piece and the circles that are in those corners
Are not
not
concentric. Oh yeah, I actually like that because
small as shit, but it's enough that I can't connect the center.
yeah, that's cool, huh? What it's because we're so used to it always being that relationship, but I think I've even said when when we've done all these drawings before, it's always been something that's actually it's always sat uneasy with me that we always assume that they are because I like situations like this where they're not. Like I'm on my center layer and I'm gonna do what you just were. I'm gonna like drop this center mark here. That's that, and then I'm gonna drop this center mark. Yeah, look at that. So annoying. But
Do we want the parts for those village things?
I think that I didn't put. I bet you I only put like because I don't think my finished drawing looked like that. But let me look at what it's. I think it.
I'm pretty sure there's thunder on one side and not on the other.
Oh, like over here they might be.
The equal
That's even worse. No, I like it because
0.035. I think it was a 2.04.
oh, I love that.
Circles are the same distance.
This is just realized some machinist somewhere made a part back in the day.
We're matching
To
it.
make a part, and that is messed up part.
Yeah, you're like, he didn't center this. Everything's, but we got to make it this way now. Exactly right.
Yeah.
We're supplying a spare part. Yeah, we're in spare parts sales again. And we're like, what do we got to build? This freaking gasket. I thought it was symmetrical. So you've already sent out one that was symmetrical build because you thought that's what it was. And then the customer's like, that doesn't match my thing. I'm like, well, what? Let me look a little closer. Holy crap, this thing's been built backwards or slightly off. That happens too. Custom part coming right up. Um, but yeah, that's actually so like that's I'm awesome that you point that out because that's why like on all the other previous assignments I've been like, well, it doesn't say they're not, it doesn't explicitly show they're concentric or not. So you always proceed with caution in those situations. Just because there's an outside corner radius doesn't mean I'm always like concentric to it. Yeah, and this is a good point of that. It's like slightly off. But the devil's in the details and the functionality of a part's kind of in its details. So cool, cool, cool. I love it. And it looks like to me when I finish, I didn't show that because I think it's maybe that would look like maybe cause more confusion than not. But then it also, I feel like maybe what's a little misleading here is I probably should tuck these center lines maybe away. Like I think I tucked this one in because it was conflicting with my radius call out here. So I think I've strategically like tucked this in so it doesn't hit my text. Maybe I should have done that here just to kind of maybe show someone so they don't when you see this, my mind is immediately, oh, I think these are probably concentric just because their center lines would overlap like this if they shared the same center line and maybe it might be something to help alleviate confusion by tucking these in, breaking the rule just to show that hey, I'm only center line of hole. I'm not center line of radius. So I don't know what the best case scenario is there, but
Or you can just make a table of dimension, not dimension it, but no one can make it.
yeah, don't let them assume anything. Assume nothing. Yeah. Because it's funny that yeah.
difficult.
That's good. Hey, that's real life situations. Yeah. Yeah, totally. These are real life situations. That's good.
Literally off by 0.005.
Oh, that's 5,000. That's huge.
That's perfect. That's way too perfect. Yeah, a perfect 5,000.
Strategically. Yeah. Yeah, if it was just random, it'd be some real random weird thing. So it is, but yeah. Good point. When you're looking at those differences, if they seem like they're a nice clean number, ooh, that might be important. No, it's good.
They're split on one half of the part and then not on the other.
Concentric over here. Yeah, that's funny.
The lead through is the machine that made his part
Slip.
stretch.
Yeah.
On one end. So. Yeah, the longer distance one direction than the other.
I think so. Wait, hey, that is what has to. It's funny that hey, I've trained you guys that.
You just have to like justify it something why you're doing all that. We're saving the world.